Bismillahirrahmanirrahim. Assalamu alaikum class. Let's start the third part of lecture 3. In the previous two lectures we have studied histogram and the bar chart. In this part we will study first the multiple bar chart. In multiple bar chart we have two or more characteristics against one common variable. Okay. In what is difference between bar chart and multiple bar chart? That is, in bar chart we construct only one bar against a variable. There is only one characteristic of a variable. In multiple bar chart we can have two or more characteristics of a common variable, and we will construct each bar against each characteristic. This is a very useful chart to compare two or more characteristics of the same variable. This is a common layout of a multiple bar chart. We can see there are two bars against one variable. Okay. Now we have an example. Draw multiple bar chart to show the area and production of cotton in the Punjab from the following data. Here we have an data of 3 years, and for each year we have two characteristics, area and production, and we have to construct a multiple bar chart. What we will do, on x-axis we will have years, and on y-axis we will have a scale that will be appropriate for both the characteristics, area and the production. Now we will have (1965) to 66. Next one is 1967 to 1968. Next one is 1969 to 1970, and the last one is 1971 to 1972. On y-axis we'll have scale like this. $1,200, $1,800, 2100. Oh, sorry, 2400. Sorry. The 8,000. Now, as we have to construct two bars, for this you have two ways to construct the two bars. Either you can use two different colors to construct the bar, or you can shade bars according to your choice. For first 1965, we have area 2866 and production 1588. It will be somehow over there. Okay. This will be the bar for the area, and for production we use color black will be not be that much visible, differentiable. Let's have orange, and the value was 1588. It will be somehow 1588. Okay. Now for year, now for year 1967 to 60. Now for the second year, 1970 to 71, area is 3233. That will be somehow over. What about this? Okay. To save time, we will first draw the third bar of area, that is 3420, and it will be some more higher than 32, like this. Now we will draw bars of production, and 2229, it will be somehow over here, 229, and the last one is 1937. Okay. This is yellow shows production and the blue bar shows area of the field. Now we will have frequency distribution for discrete data. We have studied frequency distribution for continuous data. For continuous data, we construct when we construct frequency distribution, we have class intervals, class boundaries, class marks, and tally and frequency, so on. When the dataset is discrete, it means the value of variable cannot be in decimal. It must be in integers. So class boundaries and class intervals are not useful in that case. When the dataset is discrete, we will see how we make the frequency distribution. First, we will see how you will get to know that this is a discrete data. In the last example, in the example when we convert ungrouped data to the group data, frequency distribution through tabular form was the weight of, I guess, 60 apples. That was weight. So the weight can be integer and can also be if decimal. But here the statement is a survey of 50 retail establishments had assistants excluding prioritors as follows. Had assistants. Now the number of assistants cannot be continuous, cannot be a decimal number. The number of assistants can be 1, 2, 3, 0, 1, 2, 3 and so on. So here the variable is a discrete variable. When we have a discrete variable, the frequency distribution will be like, we will have number of assistants. What is the variable? Number of assistants. And you can represent variable with any variable of your alphabet of your choice. Here we express it by x. Okay. Now let's see what is the minimum number of assistants, that is 0, and what is the maximum number? It is 9. Okay, so we will make frequency distribution from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. To make frequency, first we will have a tally bar column. Tally bar is very useful to calculate frequency. And the last one will be the column of frequency. Please excuse for the writing. Frequency is always represented by small f. Now we will make tally. First value is 2. We will make 1 bar against 2. Second is 3. We will make 1 bar against 3. Next is 9. 0, 4 हमारे पास 2 times आ रहा है. We will make 2 bars. Next is 1, 4 and 5, 4, 8, 4 and 5, 4. 8, 5, 3, 6, 0, 2. Okay. So we will continue like this and complete our tally bar, and then we will count our tally bars and write the frequency over there and complete our table, and the table final form will be like this. And the sum of the frequency must be the total number of observations, and here the total number of observations was 50, so the sum of frequency will be 50. Okay, this is all for the part 3 of lecture 3. Thank you.